Okay, hello everybody. Welcome to the first seminar in the International Year of the Salmon, the IYS seminar series. We're really excited to have you here. My name is Aiden Schubert and I'm the IYS coordinator for the North Pacific region. First, I'd like to start by acknowledging that the IYS Secretariat is located on the unceded ancestral and traditional territories of the Musqueam, Squamish and Tsleil-Waututh nations. And we thank them for taking care of these lands and waters that have sustained salmon since time immemorial. So how the seminar will work is we'll have a short presentation by the IYS director, Mark Saunders, to give some background on the high seas expeditions, followed by our expert panel discussion. And then we'll conclude with a 15-minute Q&A period where we'll open the floor to questions from yourselves. And to do so, you can do that using the raised hand function, which will enable you to ask questions with your audio as we unmute you, or alternatively through the Q&A function, which will enable you to type questions. All questions welcome. And lastly, I will just mention that we are recording this seminar and it will be available on the IYS website within the next week or so for any colleagues or friends that missed out today. So with that, I'll pass it on to Mark. Thanks.
Yeah, thank you very much, Aiden. As Aiden said, my name is Mark Saunders and I'm directing the International Year of the Salmon. I'm in Vancouver. Actually out of my house in Chemainus, British Columbia on Vancouver Island. Our office is in Vancouver, British Columbia, the head office of the North Pacific Anadromous Fish Commission. And I just want to welcome you to the first of our fall series of seminars. And I'm just going to show you in a second here those, but the topic for today is around salmon in the open ocean. Can high seas research inform challenges in salmon management? So I'm going to give you a little bit of presentation around some of how we got here, our interest in high seas work, and the panel that we've got today to talk about it. The seminar series, things you can look forward to. I'm not going to go through all of them here, but the next one that we're coming up with is around the secret lives of salmon. So we'll focus on results of some earlier expeditions that many on our panel today were part of, if organizing, if not at sea, and work through issues related to it that I hope will be of interest to you going forward. So you'll find more information about the seminar on the websites, etc. Today, the topic is around salmon in the open ocean. Can high seas research inform challenges in salmon management? And it's a topic that I think is controversial. It gets the panelists of experts and colleagues I'm really excited to have with us. It is controversial, and some of it's a thought that there's a lot going on in the ocean. We know that in relation to the condition of salmon right now and for the last 20 years. The question around what can we learn from being in the ocean, and does it matter in terms of our salmon management? So I'll get a little more detail on those questions just before we go to our panel. So maybe the next slide there, Aiden. So I just want to give you a little bit of background on how we got here, the International Year of the Salmon. There's no question we're a rapidly changing world. The IYS was all International Year of the Salmon is a 5-year initiative ending in 2022 that was all around setting the conditions for resilience for salmon and people in a changing world. And well, it was a pretty spectacular set of 5 years that we picked for the International Year of the Salmon, because the marine heat waves and the changes that we've seen, the implications for all of our species, whether in the North Pacific Ocean or in the Atlantic, where in fact it's even the conditions are even more severe. I think what our partner in the Atlantic, the North Atlantic Salmon Conservation Organization, the RFMO there, they're dealing with horrific declines that have all started in both basins in around the early part of the early 1990s and have persisted with changes in distribution, declining size at age, declining productivity, that we know is associated with everything from early marine entry to potentially the high seas. So a lot of what we're about in the International Year of the Salmon, one of our priorities is to get back into the high seas and to start to understand the mechanisms that are affecting and driving salmon productivity and learning what we're going to need to know to manage going forward in a period of incredible uncertainty that salmon are facing right now. So the next slide. Yeah, that's just a snapshot of the International Year of the Salmon. We've had 5 countries in the Pacific, Canada, United States, Japan, Korea, and Russia involved since early days of setting this up in 2016 to 18. And as I say, we plan to wrap in 2022. So next slide. I just want to acknowledge our partners, some of which are donors, but a big part of what we're doing here is recognizing that when we need to do high seas research or really anything to do with salmon is so complex, the science, the management, that trying to do it in isolation as an agency or even a country, this is really going to depend on, our success is going to depend on international cooperation, and our international high seas work is really a place where there has to be cooperation. The area is too vast and too complex that it's well beyond the capacity of one government or agency to do this work. But those are some of our partners. And we'll go to the next slide, please. So yeah, I just want to talk about going into the high seas. We got one of our panelists today, Dr. Dick Beamish. Dick and Dr. Brian Riddle with the Pacific Salmon Foundation were instrumental in trying to push and getting some momentum and going back into the high seas. And in this slide, which is outlining an expedition we have planned for 2022 with all 5 countries, 5 areas with 4 ships, a Canadian vessel, the Franklin, the NOAA vessel, Bel Shimada, and 2 Russian vessels, the Kaganovsky and the Tinro. The Tinro will be under charter. And we'll go into this area to do a Pan-Pacific ecosystem survey of the entire northeast epipelagic ecosystem. So it is building. You can see a little grayed out area there. Just in here, I don't think you can see my, sorry, you can't see my, oh, there we go. Thanks, Aiden. So that's, there's an area where the earlier expeditions to the Gulf of Alaska in 2019 and 2020 winters were conducted on board the Kaganovsky and a Canadian research vessel, or a Canadian commercial vessel that was repurposed for research, the Pacific Legacy. So we've got some early results, and that'll be the subject of session 2. But this is a large endeavor of getting back into the ocean. So we'll just go on to the next one. So I'm not going to spend too much time, but really we haven't been into the open ocean for many decades in sort of a large synoptic way to understand what's taking place out there. The main purpose of the expedition is around demonstrating the utility of an international pan-Pacific winter ecosystem to understand how increasingly extreme climate variability in the North Pacific Ocean and the associated changes in the physical environment influence the abundance, distribution, migration, growth, fitness, and survival of Pacific salmon and the surrounding species. So many of you today, and it's nice to see, I think when I checked, we had about 50 people online and we've had over 100 registered. So a lot of you will be familiar with some of the issues we're dealing with in relation to these, to this changing distribution and productivity, namely issues around carrying capacity, around competition, and hatchery production. Are we exceeding the carrying capacity with the number of fish that we're putting into the system, and particularly pinks? Trying to understand where fish are in relation to mechanisms that are affecting their productivity in the ocean, taking advantage of new technologies. A lot of the work that was done out there in the past did not have the benefit of molecular genetic techniques, the detailed stock ID that we have right now. And we've also got newer technologies that can allow us potentially to do some of this work remotely using gliders and sail drones, which we'll be testing as part of this early work. And eDNA is now something we're working with. Can these tools allow us to understand distribution? Can this start to play into forecasting? One of the hypotheses we were testing was that year class strength was set at the end of the first winter for a cohort, and if that's the case, then a survey in this particular time could be of value in terms of forecasting in season and for subsequent seasons. So there's a lot that can be gained. So go on to the next one. Before we just get into the meat of it, I just want to point out that this expedition, the 2022 and the two that have gone before, proof of concepts, we've submitted a UN decade for ocean science proposal that we understand is a very good, in all likelihood, will be endorsed by the UN in the upcoming month. But we put in a proposal to expand on, continue this work through the UN decade through 2030 to develop an ocean science intelligence system of monitoring, research, and analytical approaches that will provide timely knowledge and advice to decision makers about the impact of current and future climate on ocean conditions and high seas and coastal social ecological systems. So we'll talk about that more as the seminar series goes on, as we have updates. But we're the work that we're doing right now, the expectation is will be a legacy from this to work into a much bigger program to see this work continue. So go on to the next one. So if you have questions on what I've talked about the International Year of the Salmon, about where this is going with the UN Decade Project and others, there's some contact information, and feel free to reach out to us. So the next slide. So our panel discussion. We've got about 45 minutes, as Aiden pointed out in their hour here. So the intention is to work through a series of questions, and we'll see how it goes. This might get lively, and we might not get through all the questions. So the next half hour, I'm going to ask our panelists to introduce themselves, and then we'll start working through these questions, and we'll come back at the end for 15 minutes for questions that you can either put your hand up for using the hand tool, or you can type into the chat. So in terms of the questions, the first one I had there was, given we have no control over what happens to salmon at sea, why should we be putting money and resources towards high seas research as opposed to investing in freshwater restoration or enhancement activities? In your opinion, what is the most important management issue that could be addressed by high seas salmon research? Can you speak to the importance of international collaboration on high seas research to inform management? And how can high seas research help address the major uncertainties that salmon and people that depend on salmon face with climate change? So if you can go on to the next slide.
I think that's our last one there, Mark.
Great. So you can take it down, and we're just gonna have a conversation around those questions. And so that first one, given we have no control over what happens, why should we be putting money and resources towards high seas research as opposed to freshwater restoration enhancement activities? And I'll just note, I apologize. We need to do a round of introductions so you know who's talking. I got ahead of myself there. I'm excited about our panel, colleagues from Canada, the United States, Japan, and so I'm excited to have them with us. So maybe we'll go furthest afield. And Urawa-san, would you like to introduce yourself, please?
Thank you, Mark. Hello, everyone. I'm Hiko Urawa from Sapporo, Japan. I have just retired from Japan Fishery Research and Education Agency. but still continue salmon studies as a guest scientist. My research has focused on distribution and abundance of Japanese jam salmon in the ocean. I had several experiences to be both on high sea research vessels in Bering Sea and North Pacific Ocean, including 2019 winter expedition in the Gulf of Alaska. I am honored to serve as a panelist. Thank you.
Great. Thank you, Urawa-san. Nate Mantua, please.
Hi, Nate Mantua from Santa Cruz, California. I'm in my home office, and I work with NOAA's Southwest Fisheries Science Center and lead our landscape and seascape ecology team. And most of our work is focused on California salmon and all the habitats that they use, which includes high elevation watersheds in the Central Valley and in coastal systems, some large estuaries, and at least our fish tend to stay pretty limited to the California current, except for steelhead, which do, we believe, spend a lot of time on the high seas, but we actually don't have a great deal of information about that. So yeah, my interest is really, and expertise is in climate and how that affects various salmon habitats and their food webs.
Great. Thanks, Nate. Dick Beamish.
Dick Beamish. I'm here at Nanaimo in the on Hammond Bay. I retired from the Pacific Biological Station 10 years ago and have continued working on the ocean life of salmon. But what I thought I would tell you, which I don't think I've told people before, is I've been working on the climate and atmospheric transport impacts on fish for probably 55 years. And that all got started in the mid-1960s with the discovery of acid rain in North America. So what is relevant about that is that I connected with people in the 70s and 80s trying to convince people that climate was a major factor. And it's only been in the last 20 years that we finally started to realize the relevance of climate on fishes and salmon in particular.
Thanks, Dick. Brian, are you there?
Yes, I'm here. I'm Brian Wells. I work now at the Southwest Fisheries Science Center and the Northwest Fisheries Science Center. My work has really largely been based in understanding how variability in the forage and seascape affects salmon survival at sea, their distribution, and how these ecosystem interactions can affect salmon recruitment ultimately. Largely California salmon, but we're moving north.
Great. Thanks, Brian. Laurie.
Yeah, my name is Laurie Weitkamp. I work for NOAA Fisheries, Northwest Fisheries Science Center. I'm based here on the Oregon coast. I work on salmon in the estuary and ocean, trying to understand the factors that affect their survival, and also kind of keeping a tab on what's been going on across pretty much the Northeast Pacific since we started having these series of marine heat waves. And Dick totally buttered me up and convinced me how to go out in 2019, despite 4 people telling me that I was crazy. And it's been a really wonderful experience. So, and I'm the US lead or co-lead with Ed Farley from the Alaska Center for the 2022 expedition.
Great. Thanks, Laurie. Okay, now we can go back to the question around, given we have no control over what happens to salmon at sea, why should we be putting our resources to understanding what's going on in the ocean versus fresh water? And I'm going to go to Dick because I know this is a passionate topic for you, Dick. So go ahead if you want to take a shot at that.
Just a couple of minutes to say this. There's a few things here. First of all, when we're talking about, let's call it the open ocean work, this is simply an extension of the coastal work that we started in North America around the mid-1990s, but the open ocean work was done in Asia before that. So the people that say what Mark Saunders read out to you, what they are saying really is not relevant to what we're doing. What we are doing is we're basically trying to understand what resilience is in salmon. And to some extent, even though we say that we're studying the effects of climate and ocean on salmon, what we are really studying is the ability of salmon to survive in a changing ocean ecosystem. And everybody in North America knows that we were covered in ice out in this area where we are now 15,000 years ago. And over the next 15,000 years, salmon have survived and colonized right up into Alaska. So salmon have the ability, the resilience to adapt to changing ocean and climate conditions. And anybody that went to school learned in ecology that the abundance of plants and animals that produce a large number of seeds or babies is not determined by the number of seeds or babies, but by the available habitat. And the available habitat for salmon is the ocean. There's always we're not saying that the freshwater component of the life history isn't important, but the habitat that regulates salmon abundance, the available habitat is in the ocean. So anyone that suggests that we are wasting money by studying salmon in the ocean, first of all, forgot what they learned in university about ecology. And secondly, that what we are really doing is trying to understand resilience as it relates to the ability of the various populations to adapt naturally to the changes in the ocean carrying capacity, which is a function of climate. And I'll have more to say about that later.
Okay, thanks, Dick. Now, Brian, I'm going to go down to you. I know this area of overlap between freshwater relating to the coastal and high seas is an area. What are your thoughts on this?
Yeah, I think the question itself is always a bit misleading when it starts off, and you're not the first one to ask it this way, that you can't do anything in the oceans, why are we there? But in fact, if you put the salmon within their life cycle, things that happen in our control in freshwater, whether it be dam management, flow, temperatures, and the like, affect the demographics of salmon leaving and going into the ocean. And if we can understand how different demographics or carryover effects in freshwater act towards mitigating or enhancing mortality or survival in the sea, then we can actually change our management practices to deal with varying sea conditions. In other words, let's say we want to put out, we want salmon to go out larger. On average, that may work better, and we learn something from that. But in an increasingly variable sea, perhaps large isn't the greatest thing. So by keeping track of how demographics of emigrating salmon relate to the ocean conditions they experience in terms of their predation, in terms of their growth, in terms of their disease, in terms of their ability to find prey is extremely important. So I think ultimately what I'm arguing is that it's not that ocean is out of our control. It's that we need to look to the right levers to mitigate the variability that the ocean offers. And those levers may in fact be in fresh water. If we are to believe that that early mortality period is the one that sets recruitment largely, then fresh water is going to be our levers. And you can't evaluate the efficacy of freshwater practices without looking at it in the context of their interactions in the ocean. And that's what we do when we go in the ocean. We look at salmon when they're young, and then as they age, we relate those survivors, their early growth, their sex, their distribution. We look at the survivors at sea and relate that to the total population characteristics of fish we're leaving, and the deficit between those two then tells us who's dying and allows us to inform better management going down the line. A long-winded way of saying, yes, we can't control the ocean necessarily, but we can control levers that make salmon more capable of dealing with the ocean.
Yeah, so I'm going to go to Laurie. I saw you nodding your head there, Laurie, when Brian was talking. You're, I think, a rare beast in that you work in both the sort of lower river reaches of the river, the immediate entry estuaries, and you've now been to the high seas with Dick luring you offshore. So how do you see this?
I really agree with Brian in that there are these carryover effects. You know, we are affecting the size and timing of fish going out into the ocean. And I feel like we've understood there's enough sampling going on in the coastal ocean where we think generally most mortality occurs. But what happens when they leave there? That's when they go into this black box that we don't even know where they are. So I think it's really important to, you know, try and start opening up that box and understand what is going on the high seas. Another issue is that a huge number of hatchery fish get released every year. There's a lot of talk about competition between those. I mean, it's in the billions of salmon. And what is happening on the high seas? I mean, many of you are familiar with this even odd cycle of pink salmon that they're seeing in everything from seabird colonies to other species of salmon, even killer whales. How do have we reached carrying capacity with the ocean? What is going on in the high seas where, you know, salmon from across North America, across the Pacific Rim are mingling? So really trying to understand the effects of some of our activities that are taking place in places that we don't normally study.
Yeah, thanks, Laurie. So mingling species in the middle of the ocean, and Urawa-san, that's you've done a lot of work on chum and very interested in those chum that are mingling right from around the Pacific Rim in the center of the Gulf of Alaska. What is your take on the importance of this ocean work to management of salmon and chum in Japan and Asia?
Yeah, we are conducting annual monitoring survey in Bering Sea by Japanese research vessel every summer since 2007. And the main purpose is to monitor the status of Japanese chum salmon and their habitat environment in Bering Sea, because Bering Sea is important feeding habitat for chum and other salmon in summer. And as you know, most of Japanese chum salmon are hatchery origins. Then I think it is a mandate to monitor their status and relationships with other stocks in the ocean. In addition, high sea data are useful for short-term and long-term forecast of salmon production, which are fundamental information for salmon management. Thank you.
Yeah, thank you, Urawa-san. So Nate, you're a climatologist and you have a very big overview and understanding of these systems. What's your take on the importance of the working out in the ocean?
Yeah, so one of the key things to me that we're facing is a very rapidly changing ocean, in that its physical and chemical states are starting to enter places for which we have no historical records. And we know this is true with different dimensions that include the pH, just from the uptake of carbon into the ocean, and heat content and temperature. And, you know, like Dick, it's just not that long of a history of people looking at climate and salmon on the high seas or even locally and regionally. But 20 years ago, I don't think any of us would have thought that we'd have a whole series of marine heat waves in a 5 or 6 year period like we're in the midst of right now. It's not over yet. It's actually ongoing today. The North Pacific has just been really warm much of the period since about fall of 2013. And a lot of this exceptional warmth has been centered in the subarctic seas where salmon make a living. And that's starting to push temperatures to levels that, at least based on the high sea survey data from the 50s up through the 90s, suggests that it's not where they like to be. Catches start to drop off when you get into 13, 14 degree sea temperatures for most of these species. And we're having a lot of that lately in places that were high catch areas in earlier decades. So I think there are some really big questions about where the thresholds for productive salmon habitat are on the high seas, and how does this change the character of the interspecific interactions that Laurie talked about with pink salmon, showing evidence of having impacts on different stocks of salmon, different species of animals that are in those same food webs. And in a lot of ways, you know, I look at these recent years as a preview of a shrinking ocean for Pacific salmon. And it's happening when the total abundance numerically is at record high levels because of the incredible abundance of Russian pink salmon mostly. So this is a new world, you know, biologically, physically, chemically, that we're already in, and based on, you know, the best available science, it suggests that these kind of changes are going to continue for many years, certainly through our careers. And we frankly don't have a great understanding for what they mean for the North Pacific salmon system as a whole, and then to bring that back to the scales at which people live and fish and interact with different populations of salmon.
Yeah, no, thanks everybody. The second question I had was around, in your opinion, what's the most important management issue that could be addressed by high seas salmon research? And I think a lot of you in your answers to that first question touched on a lot of management issues relating to forecasting, competition, hatchery production in relation to carrying capacity, et cetera. I won't go around the panel on this one, but I'll just open it to the panelists. Do you have anything else you wanted to add in terms of management issues that you're seeing could be informed by high seas research?
This is Brian. I think a low-hanging fruit is the development of process-oriented indicators of salmon recruitment and survival. When going to sea, if you can find physical and biological drivers of salmon distribution and condition and maturation and so forth, and then link them in some way to, say, remote sensing or biophysical modeling efforts. And what you're doing is you're actually setting yourself up well to have indicators of return numbers, mixed stock distributions, and the like. So again, a long-winded way of saying these surveys allow us to develop the processes to allow us to have indicators that we can do off-board and from land to, going forward, address what we think salmon will be next year, the next year, and then into climate change potentially.
Let me just talk a little bit about British Columbia, because we're talking about management. And very briefly, our history is that in the 1970s, some of our best scientists, Peter Larkin, Bill Ricker, Peter Larkin said that he thought that there was still, and he used the term, plenty of headroom left in the Pacific to produce more salmon if more juveniles, more babies would be added. And so that's what we started our so-called salmon enhancement program, or our hatchery program. And that was in 1977. And that was because our very best science at the time believed there was unused carrying capacity in the ocean. So you fast forward to 2005, our best scientists, and I think everybody will agree those are pretty good scientists, their forecast was the commercial catch of salmon in British Columbia in the 70s was 70,000 metric tons. And their estimate was by 2005, our hatchery program would produce a commercial catch of 140,000 metric tons, double. So by 2005, a commercial catch of 140,000 metric tons. In 2019, our commercial catch was 4,000 metric tons, all right? Not 140, but 4,000. So clearly, the concept of unused carrying capacity in British Columbia, that hypothesis is rejected. And you have to come up with a different hypothesis. Well, so two things have happened. One is we have not rejected that hypothesis, and we still think that because a hatchery can actually produce fish, that represents an increase in the total abundance, even though we know for sure that that's not the case. And the other observation from what I've just said is that clearly it's indisputable that the reason our commercial catches are declining is because there is not the unused carrying capacity. And what has happened is that the carrying capacities that we saw in the 50s and 60s for salmon in British Columbia salmon have clearly diminished. And if you've got diminished ocean carrying capacities, the last thing you can expect is adding a lot more babies to the ocean is going to give you more back. So that's the relevance to management. And that relevance comes from the coastal understanding of what regulates salmon abundance. And then we need to improve that coastal understanding by expanding it to the open ocean understanding of what regulates abundance. And what I said earlier, essentially, what does resilience mean in Pacific salmon?
Thanks, Dick. Others on that topic around other management issues?
I think that, I mean, the most important one to my mind is really this being able to predict how many fish are going to come back. And I think we've got a really interesting situation where in 19 and 20, the surveys hardly got any sockeye. And lo and behold, you know, we had really low Fraser sockeye returns. And so I'm really excited to see, you know, what do we see in 2022? Is there a correlation there? Are we going to be able to, you know, use that to predict? But at the same time, there's some real surprises. So for example, we hardly caught any pink salmon. You know, they're the most abundant salmon in the ocean, at least in the Pacific. And where are they? So obviously trying to come up with forecasts for those, we need to figure out where they are first. And we haven't succeeded in doing that. So I think there's some real potential, but I think our study work so far has really showed us that, you know, it's never what anybody thinks it's going to be. Our expectations for some things were wrong, for other things that were right. But really trying to be able to forecast how many fish are going to come back is I think, an ultimate goal of winter high seas, because you're looking at the regulation of survival.
Right. Thanks, Laurie. So unless anybody else has something burning on that, I'm going to move to this third question about speaking to the importance of international collaboration on high seas research to inform management. I'm going to ask Urawa-san, and then I'm going to go to Laurie again. You two were actually together with a cadre of researchers from all 5 countries. Can you speak to sort of the importance of collaboration in this work? Urawa-san.
Thank you, Mark. You know, Pacific salmon globally migrate ocean freely crossing borders. For example, Japanese cham salmon make seasonal migration in Okhotsk Sea, Bering Sea, and the North Pacific Ocean. It is also noteworthy that most cham salmon stocks from Asia and North America cohabit in the Gulf of Alaska during winter. And it is impossible to track their migration by solo countries. We need international collaboration to monitor salmon and their habitat throughout their ocean life stages. Currently, international collaboration is well maintained by NPAC member countries. So I am looking forward to seeing new science information from 2022 International Cooperative Expedition. Thank you.
Yeah, thank you, Urawa-san. Yeah, so this is Dick has been it's a big part of what was built into the thinking behind the 2019 and 2020 expeditions, and it was really held up there as being just as important as any science observation that we were going to make, that they were going to make out there. And I happened to be on the dock when the Kaganovsky arrived, and I've never seen, you know, a group that had been at sea. I've been to sea before, and usually you don't want to talk to anybody in a suit, and they were the most excited group of scientists I think I'd ever seen come off a ship. Maybe Laurie, you were a great spokesperson for sort of the collaboration. Maybe you want to tell us a little bit about what it was like to be on the Kaganovsky and what it meant to work with people from 4 other countries on this problem.
Yeah, thanks, Mark. It was really phenomenal. I mean, just learning from each other and having the chance to talk about kind of everyone's view of the salmon world, because I think, you know, you come from different organizations and you kind of have this view of what goes on out in the ocean, and really to have that much time where, you know, we'd work together, but then you're also hanging out together. And to get a different view, I thought it was really wonderful. For example, talking to Hiko-san about chum, and, you know, I learned an incredible amount talking about to the Russians about what they thought about pink salmon and how they worked, you know, what their factors were, you know, as well as the Canadians even, and spent a lot of time talking to the Canadians about, you know, the importance of what's going on in Strait of Georgia, that you really you can't get that level of interaction from. I've been to lots of international meetings, and, you know, the Russians kind of go off to one place, the Japanese keep together, the Americans and the Canadians kind of talk to each other, but not really, because we can't just agree on beer or whiskey. And so it's really a unique opportunity, I think, to really get to know people and get to know them both scientifically as well as personally, so that I'm, you know, when he goes on to ask something, I know exactly what he's asking. I know, yes, I'm happy to help you try and do this, as opposed to who's this guy kind of thing. So these personal relationships, I think, are really, really important to overall project success, as well as just, you know, learning what other people think about the ocean from the different side of the ocean is really valuable.
Great, thanks, Laurie. Okay, we're about 4 minutes away from sort of opening it up to questions. So, folks that are out there, if you're got some questions for the panelists, you can address it to the panel and look for an answer, or you can address it to someone specifically. You can put your hand up, or you can put things into the chat, and we're monitoring that to get the questions out. So we've got about 4 minutes before we do that. So is there anything else that panelists wanted to, I'm going to bypass the final question there, but is there anything that panelists want to get off their chest before we open it up?
Yeah, Mark, I'll just say one thing that,
sure.
You know, I'm just more and more stuck on the idea that we are entering an era of surprise, ecological surprise, following off of these climate extremes as a driver to sort of cross thresholds that maybe we don't know exist. And because salmon are part of complex food webs, there are a lot of players involved. And surprising things have been happening, and I imagine that they're going to continue to happen, and they're going to continue to challenge our ability to make forecasts 1 year into the future, or even 5 or 10 years into the future. And that does point at another way of thinking about the kind of science we could do to support more effective management. And I think salmon management for much of the North Pacific has been riddled with failure, just as we can see from these collapsed stocks and collapsed fisheries and economies and communities that were salmon dependent. So it's a good time to challenge, I think, the paradigms that have got us where we are today, and to think about how we're going to deal with surprises. And, you know, one surprise that we're dealing with in California the last 2 years is a thiamine deficiency that has shown up in Central Valley Chinook salmon that looks to be related to a very large increase in the abundance of northern anchovies and successive years of low availability of other typical Chinook forage. And we have a lot more questions than answers about this right now, but here's a case where a change in the ocean is impacting freshwater productivity. And they've seen something like this in Western Alaska Chinook salmon as well, although it doesn't look to be quite as severe at this point. But there have been a number of publications and analyses showing low thiamine in some of those stocks, and it's associated with low productivity in those stocks. And just to me, the bigger issue is it's going to be hard to make predictions in a world that's changing so fast, and that science doesn't tend to work as fast as it seems to me the world is moving.
Yeah, thanks, Nate. Others that wanted to jump in with a thought before we go to questions? Okay, well, why don't we go to some questions that are out there. And Aiden, do we have anybody in the, I'm seeing Q&A there, yeah. Okay, I've got Mike Matlowicz. Hi, Mike. With reduced ocean carrying capacity, should reduced releases of hatchery salmon be one of the responses? And who gets to decide which hatchery releases are reduced? Anybody want to take on that?
I'll give it a try.
Okay, good. Way to go, Laurie.
No, I mean, that's a great question, and there aren't any easy answers. All I can say is I think it's really important that if you're going to do things like really change hatchery outputs, that we try and learn from it to the extent possible. Make sure that we're measuring the right things, et cetera, so that we really understand what the impacts are. And yeah, trying to have a North Pacific-wide reduction in hatchery production that you can actually tell that there's going to be a change. I mean, we're talking huge reductions, that it's not just one hatchery reducing by 10%. It's really major. So, but no, that's a great question. I really don't have a simple answer, except I hope we can learn something from it.
Let me just quickly say that, first of all, I'm not opposed to hatcheries. What I think is happening in British Columbia, I'll confine it to British Columbia, is that there is a role for hatcheries. And I think the original assumption that hatcheries are providing more babies, more juveniles to fill out ocean capacity, we reject that. But there is a role, I think, that where we can use hatcheries to maximize what I'll call regional opportunities for particular species. It's just that I think what we are learning is that we need to use hatcheries differently.
So what are you saying, Dick? What do you mean by using them differently?
I'll give you an example. Big Qualicum Hatchery has been releasing chum salmon later, and as we saw for South Thompson Chinook salmon that enter the Strait of Georgia 6 to 8 weeks later. And what they're finding with these late ocean releases of Chinook salmon and coho, that they're getting at least 2 times the survival. So the late ocean entry is improving the survival. That's just one example.
Okay.
Well, and I just also say that if this idea were to start to affect management, it would require a different kind of management, right? You would have to start to get cooperation among different producers and think about the shared resources that are in the ocean. And depending on the stock, it could involve all the countries of the North Pacific. For instance, if we're talking about chum salmon from Asia, or pink salmon, or from Alaska, these are stocks that are using large parts of the North Pacific with overlapping distributions. And then it would come down to some way of portioning out who gets what, and maybe would require some kind of payment system that would ease the burden for people that had to give up something. And some people have written about this. I know Randall Peterman and his collaborators have looked into some of these ideas. and others have as well. But it would require a different kind of management than has traditionally existed. That, you know, it's not a single stock view of the salmon world. It is this shared resource view.
Yeah, interesting, Nate. Yeah. Okay, the second question we got is from Marisa Litz. Says, given the evolution of new technology, eDNA, hydroacoustics, is trawling for salmon on the high seas the most efficient and cost-effective way to learn about relative abundance, distribution, etc., especially given the vast spatial area to be sampled? Excellent question.
Yes. Look at the North Americans aren't really familiar with all of the research that's gone on in Russia. What are we looking at? 25 years or more, extensive publications, all of the things that they've learned about pink and chum in particular, and then switch over to Japan with all of the research that they've done on the high seas. So it's not just that for the North Americans, a few of us are going out there for the first time. It's that high sea salmon research has been going on for decades, and we've benefited from all of that information that Russian and Japanese researchers have published from all of the high seas trawl work that's already gone on.
Urawa-san, did you want to get in on that?
I agree with Dick. Yeah. Trawl survey is the standard method to estimate abundance of salmon in the ocean.
Mm-hmm. Yeah, thanks. So,
can I jump in there real quick? This is Brian.
Yeah, go for it, Brian. Yeah.
So the key, I think, to Marissa's question was abundance and distribution. And I think that, yes, I think eDNA technology with sippers on things such as gliders and with cameras and open-end nets, things like that can be a quick and efficient way to cover a lot of ground, not only for the salmon, but for the interactions between predators and their forage. But I think that, you know, we're also correct in that we do need to collect the salmon themselves. What are they eating? What is their condition? What, you know, those types of things. What is their reproductive condition? And guesses on when they might be coming back. So I think a more hybrid approach is an approach that people like Ed Farley with the gliders is doing. We're doing it down here in the California current. So a hybrid approach of using the nets when you need to use the nets, which is individual understanding of individual fish within the system, and using higher technologies when you really are asking larger scale questions such as distribution and abundance, we'd serve ourselves well.
Yeah, thanks, Brian. Yeah, I think I agree that that the technology is there, that it's worked, everything that Dick and Urawa-san are saying, and I'm with you, Brian, that there's the opportunity for the hybrid work. As someone who's chasing money to do this one expedition, it's an expensive endeavor. And the ability to send ships to sea is not, you know, repeatedly on large synoptic surveys like this was a challenge. And I think at least on the distribution side and some of the questions we've got, that new technology is going to make a big difference. But as you say, we still need to get our hands on those fish. So it's going to be, I agree on the hybrid take there. Next question is from Karina Nichols. It says, I have heard that many salmon returns are determined during the first couple of months at sea after leaving fresh water. Do you think this is the case? And if so, how can at-sea research help us understand what may be occurring during this critical time period?
So I'll jump in. I think it is until it isn't. And we're seeing increasingly that there tends to be late mortality, and we really don't understand it. Perfect example is 2015 coho return to southern waters, Salish Sea, Washington, Oregon coast. Everything looked great when they went out. There was really good coastal conditions, and that was one of the lowest returns we've had, and the fish were really, really small, which would indicate that they did where they were. They put on a substantial growth in the last summer, and that was not a good place to be. And so that was pretty good sign of a late mortality event. And I think we should expect to see that more and more, really understand what's going on. I think the mortality schedules for most populations are starting to change. It may not be every year. Definitely most of the mortality occurs in the first year, but it really screws up your forecast when there's a late mortality event that you had no idea was coming down the line until the fish are starting to come back. And you can't tell if they're late or if they're not coming. And then you tend to overfish. So
I think there's two phases to ocean mortality. I think people know that I believe that there's strong scientific evidence that brood year strength is related to the coastal oceans, and specifically fish that can grow fast and quick are the ones that survive best. But there is a second phase to it that we don't really know much about, and let's call that the open ocean mortality. And we see evidence of that in what Nate has talked about in terms of the ocean warming and in the last few years. And 2020, the total returns to all countries, a commercial catch of a little over 600,000 metric tons, down from 1 million metric tons, I think is evidence that there is the open ocean phase of mortality, which maybe we have tended to think of as being sort of constant. We just really don't understand that well enough. So coastal ocean survival is, I think, very important, but there is an open ocean mortality that we really need to better understand.
Thanks, Dave. An anonymous question. Many salmon populations in Alaska are maturing at younger ages. Is this the case for salmon returning to other areas? Younger maturation age typically results from increased growth. Is there a resolution to the conflict between younger maturation age and the possible reduced carrying capacity and increased competition?
It sounds like one of our colleagues asked that and doesn't want to tell us who it is.
You think?
Laurie should answer that, or Hiko.
I think there's a lot of different things that go into size and age. Certainly, the hatchery practices that are promoting fast-growing fish tend to produce younger and younger fish. And so areas that have a lot of hatchery production tend to have younger fish because of that. Other factors, I don't know. And Hiko-san, maybe you can talk about chum salmon because you've lost the 5-year-olds, right?
Yeah. In Japan, number of chum salmon return is decreasing, but age at maturation is also decreasing. But we don't know why it happened. Sorry.
Other thoughts? Comment from Vladimir Rychenko. Warmer waters at sea can explain this. Vladimir, do you want to explain it? I think we have the capacity to let Vladimir come live. There we go.
Okay, thank you, Mark. Do you have me?
Yes, we can hear you. Yeah.
Yeah, in my opinion, the warmer waters which we observed last year due to blob and heat waves may increase the rate of salmon growth and maturation. It's a very typical process for poikiloterm animals. They can grow faster in a warm environment. And that is one consequences of this faster growth, early maturation, and early return. Thank you.
Great, thank you. Okay, those are a great set of questions. Some good challenges for the panel. I think we might even come close to stumping you there to some degree. But I want to thank, we're coming to the close here, and I just want to thank everybody. It's been an excellent conversation. I think we had around 80 people attending. I hope those of you in the audience that it was of interest to you. And as we provided some contact information, please feel free to come back to us. I guess I want to thank the panelists for the information, but also sort of the tenor of our conversation today. I think this is a pretty anxious time for people, whether you're a fan of salmon or not, just how serious. And I think, Nate, you really captured some of the sort of the surprises and the angst that we're heading for. And I think as we get in, as we do this is, I think the answers and ability to sort of calm our anxiety around this stuff is in the cooperation, the moving forward on the science. Like you talked about, it's a new management system that's required. It's a new system of cooperative science. Taking what we've learned, the capacity that all of our countries have is this thing can be done, and we don't have to be, we can be adapting. We can go into a climate adaptation phase where it's informed by knowledge, and as opposed to just saying there is a surprise, it got us again, and we're into another fisheries disaster that needs compensation. Certainly we're going to be in those modes, and we can be much more resilient in the way our science and our management system operates. And it's been a pleasure for me to be part of the International Year of the Salmon and be part of the colleagues that are around us on the panel today. I'm personally very hopeful, and I'm fortunate to have them around me as we work on these issues. So I hope that's been helpful for people out there, and we look forward to your comments and your questions. And we hope to see you at our next seminar as we move towards our expedition in 2022. So thank you very much, everybody. I think you'll put up a slide, maybe, Aiden, as we go out with the next seminar. So again, thank you very much, everybody. Have a pleasant morning or evening, wherever you are.